So hi guys, welcome to Placements Ready. Today's problem is post-order traversal using iterative method. Okay, so but before moving on to the problem, if you haven't subscribed our channel, please subscribe. That really motivates me to create such amazing content, right? So let's read the problem statement out. So we are given a binary tree. We have to find the post-order traversal of this tree without using recursion. So we don't have to use recursion here, right? And if you see the example input, so the output for this is 45231. So basically in post order traversal you visit the root node at the last, but first of all you try to visit the root left subtree, then the right subtree, and then finally the root node. Okay, so let me explain you this in more detail. So here you can see we are having the tree, right? So what happens in post order traversal is that you basically visit the left subtree, right? So here when you come to 4, it has no left child, right? Then it has no right child, then 4 is your root, right? Then you come back to 2, then you go on to its right, so which is 5. So 5 will be your next root to be visited. Then it comes down to 2, and then for 1 the right child is 3. So 3 is your next node to be visited, then 1, right? So this is your post order traversal which I have written here, right? But the thing is that you don't have to use recursion. So without recursion the algorithm goes like this, right? So listen very carefully. In the iterative method you can take a stack, right? Why stack, I will let you know in some time. So first of all we will take a stack, right? So let me draw a stack first. The first step is that you will push the root node, so that is fine. Now we will iterate on the stack till our stack is not empty. So first of all what you will do, you will assign the root node as the the node present in the stack. Okay, so my current root is 1, right? Now what I will do, I will first of all push the data of this node in a vector, because finally we have to return a vector in this question. So our vector will be containing 1, right? Then what we will do, if the left child of 1 exists, yes it exists, then we will push this into our stack. That is fine. Also we will check if right node of this 1 exists, yes it exists, so we will push it into our stack, right? Now what we will do, we will take out the element from the top of the stack, right? So 3 will become our root now. Now we will check if 3 has left or 3 has right. No, but before that we will push 3 into our answer vector, right? Now 3 is popped out our stack, so let's erase it, right? And 1 is also done. Now we will do the task for 2. But before doing any task, push it into our vector. Now check, does 2 have a left child? Yes, so push it, and now 2 is our root node, right? So 2 is our current root. That is fine. Now 2 also has a right child, 5, so push it into our stack. Now it will come out, so 5 don't have a left child, 5 don't have a right child, but before that push this into our vector, right? Similarly for 4, check if left child exists, right child exists. They don't exist, but before checking the left and right child, push it into our vector, right? Now as you can see, this is our final answer, and if you carefully observe our vector, it is nothing but reverse of this. So we can finally reverse our answer vector to get our answer, right? Now the intuition behind this, why I have taken stack, because first of all what I am doing, I am pushing the root, right? Then I am trying to visit the left child, then I am trying to visit the right child, right? Now stack works in last in first out principle, and the logic behind post order traversal is that you have to visit first the right, sorry, yeah, so the left, right, then root, right? So stack helps us in doing this. So what we are doing, we are pushing the root, so that is getting managed with the help of a stack. Okay, so I hope you have got the intuition behind this problem as well as the explanation. Now let's move on to the coding implementation. So here we have to return a vector, right? So we have taken a vector answer. I've created a stack S which will be of type node star. Okay, because we have to store the nodes in our stack, right? First of all, we will push the root node, and now we will start iterating on our stack till it is not empty. We will assign the top of the stack to the root and we will pop it. Okay, now we will push the root data into our answer vector, and we will check if roots left exist. If it exists, we will push it into our stack, and if root right exists, we will push it into our stack. That is fine. And finally, as we have discussed, the answer vector will be containing the nodes but in reverse order, so we have to reverse it in order to get the actual post order traversal, right? And finally we will return our answer. So I hope the problem statement as well as the explanation and the coding implementation is clear to you. If you have liked this video, right, then please like and subscribe to our channel for more such amazing content. Thanks for watching.